Um, my name is Alex Ade, student of Regis University. I'll be talking about time series analysis and forecasting of Microsoft stock price with economic indicators using machine learning. Um, so the content of my PowerPoint, I have introduction. I have so I import the necessary libraries and do some visuals and do some feature engineering, data preparation, model creation, model evaluation, and conclusion. The introduction, you talk about time series, we talk about statistical techniques that is being used to analyze different data. And this technique can be used to detect the trend that's in the data. And we call it time series because it is actually look at time, the time period within is stretched between a particular time from time period. And most we use historical data to make this forecast. Some of the machine learning models that will be used in this project is going to be LSTM long short term and the XGBoost, random forest, and SVR. A quick introduction about the project. The project we're going to use 10 years worth of data. Uh, which we're going to actually predict the stock price, Microsoft stock price. Whenever we load in the data, it's going to have the opening, the close, the high and low, and the adjusted close. But for these, we're going to use the adjusted close of the stock price. Some economic indicators we are actually going to add as a variable, as a feature to predict this. Also, it's going to be gold price, unemployment rate, and inflation rate. We're going to look at how how they actually relate with one another. Some of the necessary libraries we're going to import to work on this project are going to be Pandas, NumPy, Matplotlib, Seaborn, sklearn, and TensorFlow. The Microsoft stock price and gold price are going to be downloaded through Yahoo Finance. And the unemployment rates and the inflation rates is going to be gotten from Bureau of Labor Statistics. All data that are going to be brought, loaded into the cells are going to be mashed. And these are going to be left joined using the date column. And some of the null values in the data set are going to be filled with k-nearest neighbor inputter. This is a quick glance of what the data. This is data we made the data frame using a copy of the Microsoft stock data set, and then we match each of the other data set files that was loaded in using the date as the initial date of Microsoft as a format. Then we left join each of the column inflation, close last, which is the necessary column or attribute that is needed from good price. And for the unemployment rate, we're going to take the unemployment rate column. And whenever we loaded the data, we got the info to actually have a quick glance of the data set. And we see that they are mostly float and integer. The only object we have is the date, but we actually going to use this as an index. We check the null values. We see inflation at about 18. Close life, which is a close price of gold, it has about 57 null values, and unemployment rate has 18. So using the KNN input. We actually use that to actually fill the null values, and whenever we finish filling it, everything came out clean. There are different visuals we do in a project. Some of these visuals are Matplotlib, which and Seaborn was used. Also, we are going to actually have a deep look of what the data is actually. So whenever we do the different visuals, one of them is going to be data. We're going to use its map to check the correlation of each of the features with the target variable. We know our target is the adjusted close, and we're going to actually look at how it relates with other features. The date column, we're going to use that, of course. And would open at what that's how the price of stock when the day opens, the high of the day, the low of the day, how the stock closes, and this is adjusted close price, which is all we are going to use. We also this high correlation, but we are going to actually take off all we need in this is going to be adjusted close. Then we look at the volume. We don't really need that, so that's going to be taken out. Today it has low correlation. Anyways, we're going to take inflation. We see this high correlation, which should be within 0.5 to 6. This close class, which is the price of gold, there are multi closes. So we see this high correlation here. So we see there's a correlation between stock price and the price of gold. Unemployment, on the other hand, has very low correlation. So we're going to all the attributes that are not needed, we are actually going to drop them. So now we probably just need the adjusted close. We need inflation. We need the price of gold close. Like we're going to change the names of all this. So still looking at the visuals, we dropped the columns that are not needed. We already actually made the date as an index, so we're going to drop this. The volume is going to be dropped, the open, the close, of price of the day, the high and the low, and unemployment since it has a low correlation, so we're going to drop all that. So looking at the heat map, we see the correlation between now the name is being changed. It's see Microsoft stock price. In relation with inflation, you see the lowest of the correlation is about 0.5. So we're going to consider all this. And gold price, we see this high correlation, so we're going to look at that. Taking note, using all this, looking at another visual, we'll actually look at the scatter plot of the different features, gold price and Microsoft stock price. We see this linear relationship as the price of stock price actually goes high, the price of gold also goes high. So it's like there's a linear trend. Also looking at inflation and the Microsoft stock price, we see it seems like a linear relationship also. As there's low inflation, the price is low. The higher the inflation, the higher the stock price. So we're going to do some feature engineering to actually get a good look of the data set. So here we actually take from the date, we take the days of the week. We actually make another feature, days of the week. We make the month of the year, the quarter, and actually select a different year as different features to actually look at what the data is the data look like. So we look at from where the year starts on the data set. We see how the price of of Microsoft stocks is very low. As the year goes, so does the price. So we also actually go to look also at the different months of the year. So we see this the first 3 months we see the SI, which I think people actually make different plans to actually purchase, as in they are making plans towards the beginning of the year. So they probably put their money more into stock to look at what they can actually benefit from that. So we see that there are people tend to buy at the beginning of the year, then it goes down at the second quarter, then the trend keeps going back up. Um, so we are going to prepare our data. So the relevant columns have been selected: the Microsoft stock price, inflation rate, and gold price. Then we split the data into training, validation, and test data set. We actually add a helper function to create X and Y. I will create a list on that X and Y array. Since we are doing the time series analysis, we actually go to create have a time step of I use one as a time step to actually the end of the day we use the end of the day to begin another one to show the next day. So the training data set has 70% of the data, and we use 20% for test data set and 10% for validation. So the model that we're going to use first is going to be the launch LSTM. Where you're going to use Keras with sequential model architecture. Some of the optimizer we're going to use is going to be ADAMS and RMS-Prop. Also, we're going to fit in the training data into the model, and then we're going to make the different plots. We're going to evaluate and make plots. After we've done all this, we're going to use other models like XGBoost, Random Forest, SVR also to train the model. So the other metrics we're going to actually use to evaluate this model are going to be mean square error, mean absolute error, root square error. The visualization also, we're going to actually see what the trend looks like. The first model that was done is just a simple model where we just have a 50 layer, we have a dense layer, and we have our optimizer to be Adam, and mean square error as our loss function. So we have like 10 epoch, and six batch sizes. We have our validation data to be S val and Y val. We see that this actually fits real good, but we know here that's probably going to be issue of overfitting. So the next one, we do have some dropouts, trying to optimize this model and add other layers to it. So also we have actually include learning rate. When we did this, we see that there's a big difference between the test the test data set and the train data set. We see this difference right here. Also, we're trying working on the model again, reduce the dropout. So when the dropout was reduced, we see that, but this can be risky. It's really close. We see it's really good, but we know we have to be very careful because this is a time series and there are other factors that actually add to what the stock price might be. So we see the loss, the total loss, the validation loss, and the test loss. Yes, they are really close. So we don't want this to be too high. Using the other loss optimizer, we use the RMS-Prop. So to check what it is. So we're using the same one that was used up here, but just changing the optimizer. We see the difference. So that's and also looking at the losses. It's a little bit for the test loss, it's a little bit higher than the previous one, but which is still low though. So we see from the one where we've seen above, we see that the Adam is going to be the best one to use, and with about 3 dropouts and some layers added to the model. So going to XGBoost, I worked on this and I discovered that after training, fitting the data set, fitting the training to the model, it all came out flat. And after reading and doing some research about the test, I discovered you can using tree-based model would not actually really work for time series. So when we look at this, we see how it run the rate flat. And again, we see using the XGBoost, we've trained it up to this point. So it's not good to actually, it actually has to be trained to see the rest of the data for it to actually perform well. So you cannot really use XGBoost for this. Using random forest, also fitting in the trained data set, it came out the same way. It's all tree based. So we still have the same issue. Another model that we use SVR, we did run fitting this in a model. The mean square error seems low, but this model did not really work good like we wanted. So in conclusion, we'll say XGBoost, when we had more layers and a lower learning rate, seems to be more efficient in actually predicting the data. Adam optimizer seems to be the best optimizer that could be used for the LSTM. Also, one thing I discovered that increasing the epoch and the batch size has nothing to do with the efficiency of the model. Also, we see XGBoost, random forest, and on SVR. The predictions came out flat, so we can actually use that to predict the stock price. So after getting all this the flat prediction, I see that I read difference in the target may actually improve what XGBoost or XGBoost random forest as well might produce. But I've not actually done that. I'm actually going to take a look at that. Some features also that I know that could actually help in prediction of stock price. Could be like I know when I've actually trade forex before, and we talk about what the news, what is the public saying. So that means sentiment analysis could actually have something to do with stock price prediction. I'm looking at it, what happened about 2 years ago when GameStop price went really high, and this is what the media actually contributes to. And we say Elon Musk actually did the same thing. We drove the price of Bitcoin up when it said it was going to use that to accept the purchase of Tesla. In this project, we're able to analyze and predict Microsoft stock price with some economic indicators of such inflation and gold price. It came out to be good. We created an LSTM model that's able to capture the complex pattern and the trend in the data. Time series, so can be used to actually do make various prediction, like in finance, in economics, in business. But one should be very careful whenever making these predictions. Thank you.